Hi, and welcome to Higher Order Polynomials Day 2. Today we are going to be solving higher order polynomials algebraically. So, what is a higher order polynomial? Well, it's a polynomial where the largest exponent is greater than 2. And in this case here, in this example, my highest power is 5. Therefore, it's a higher order polynomial. The image to the right is an example of a fifth degree polynomial, which means that there will be no more than 5 real roots. Circle the roots on the graph. Well, my roots are where the graph crosses the x-axis. So as you can see there, it crosses it in 5 different places. Therefore, I have 5 roots. Okay, these are known as the roots or the solutions or the zeros. In order to solve algebraically, we must start by factoring. So let's try a few examples. For number 1, I have x cubed minus 3x squared minus 4x plus 12 equals 0. I have 4 terms. If I have an even number of terms, I'm going to look for grouping. So if I group them, in my first set of parentheses, my GCF is x squared. So it's x squared times x minus 3. In my second set of parentheses, my GCF is negative 4. And I'm left with x minus 3 equals 0. Now my new GCF is x minus 3. And I'm left with x squared minus 4 equals 0. Okay, I can keep factoring that, so I will have x minus 3, and then x plus 2, x minus 2 equals 0. So now I set each factor equal to 0, x minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So x equals 3, x equals negative 2, and x equals 2. So these are my roots or my zeros. These are my final answers. My highest power is cubed, and I have 3 possible answers there. For the next example, we will have to factor first and then use the quadratic formula. Not all quadratic factors are factorable. So this does not have an even number of terms, and that's one of the clues that you're not going to be using factor by grouping. First thing I need to look for is a GCF. My GCF is x, and I'm left with x squared plus 2x minus 2 equals 0. Well, x squared plus 2x minus 2 is not factorable at all. But I'm going to take each factor and set it equal to 0. And I'm going to take the factor on the right and use my quadratic formula. So a is equal to 1, b is equal to 2, and c is equal to negative 2. So we use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, it would be negative 2 plus or minus the square root of 4 minus 4 times 1 times negative 2 all over 2 times 1. So x equals negative 2 plus or minus the square root of 4 plus 8 all over 2. So x equals negative 2 plus or minus radical 12 over 2. So we'll keep going. X equals negative 2 plus or minus, well, 12 breaks down to 4 times 3, so 2 radical 3 over 2. Both of those are divisible by 2, so x equals negative 1 plus or minus radical 3. So my solutions are as follows. X equals -1 plus radical 3. X equals -1 minus radical 3. X equals 0. We have to forget our very first root that we found. Solve algebraically. If I have 4 terms, I look for factor by grouping. In the first set, I will have x squared. To my left, x minus 2. In the second set, my GCF is 9. That's with x minus 2. So now my GCF is x minus 2, and then I have x squared plus 9 equals 0. X squared plus 9 is not factorable because it is not a difference of two perfect squares, it's a sum of two perfect squares. So x minus 2 equals 0, and x squared plus 9 equals 0. So over here, x is equal to 2, and on the other side, we'll say x squared is equal to -9. Take the square root of both sides, so x is equal to plus or minus 3i. Don't forget your plus or minus, and don't forget your I. So my solutions are x equals 2, x equals -3i, and x equals 3i. We could have used the quadratic formula as well if we wanted to. It's just, for me, easier to do it this way. All right, last example. Is to a root of the equation x to the fourth minus 5x squared plus x plus 2 equals 0. Well, to see if it is, we're going to take x equals 2, because if 2 is a root would be x equals, so x equals 2, and we're going to substitute into my equation, which is x to the fourth minus 5x squared plus x plus 2 equals 0. So what I'm going to do is then put 2 in place of x. So 2 to the fourth minus 5 times 2 squared plus 2 equals 0. 2 to the fourth is 16. 2 squared is 4 times 5 is 20. Plus 2 equals 0. So I have 16 plus 2 is 18 plus 2 is 20. Minus 20 equals 0. So 0 equals 0. Since it checks, we're going to say yes, x equals 2 is a root. If it didn't check, it would not be a root. So in summary, when solving a polynomial of degree 3 or higher, look for the following. Factor by grouping when there's 4 terms. A monomial greatest common factor if there's 3 terms. This may be the case where you have to use the quadratic formula.